All right, let's dive right into this explainer. Have you ever considered that the very code we write, the fundamental technology we're building right now, might actually be a mirror revealing the absolute deepest secrets of our universe? Today, we're going to look at one of the most powerful tools in modern computer science and see it for what it truly is.
We're going to explore how artificial intelligence creates a literal multiverse of its own, and how this process might just give us a glimpse into our own incredible hidden power. We are digging into the Conscious Singularity Hypothesis. And, believe it or not, understanding this massive cosmic concept starts with something as simple and, honestly, kind of hilarious as trying to teach a computer to recognize a cat.
So, let's start with part 1, the AI's dilemma. To grasp this profound connection between code and reality, we first have to tackle a really basic engineering challenge. Imagine you show an AI a beautiful, perfectly framed photo of a cat. We can call that the prime reality. It's upright, perfectly lit, super easy, right? The model learns, okay, that's a cat. But what happens when you throw a messy reality at it? Say, a cat that's blurry, rotated 90 degrees, or hiding in the shadows. If you only train an AI on one perfect reality, it completely fails when it hits the messy real world.
In computer science, this failure is called overfitting. And the implication here is really interesting. Overfitting means the machine just memorized the exact pixels of that perfect image, rather than learning the actual underlying concept of the animal. To fix this, we have to force the AI to discover the true essence, or what engineers call the invariance of catness, across all sorts of disparate conditions. But we don't have infinite real-world examples to feed it. So how do we pull that off?
That brings us to section 2, parallel streams of thought.
To solve this dilemma, engineers rely on powerful computational architectures that, remarkably, mirror theoretical physics. Enter parallel processing. When we feed a machine learning model a massive dataset, frameworks like TensorFlow set up multiple, entirely independent data streams. Basically, each core on your processor acts like a distinct parallel universe, processing different images and unfolding at the exact same time. It is our first major clue that these machines operate in ways that completely transcend a single linear timeline.
Think of this as a physical metaphor for consciousness itself. First, the vast dataset pours in. Then it splits across multiple CPU or GPU cores. Finally, the system processes all these independent realities simultaneously. What we are really looking at here is a mechanical stand-in for a consciousness that is processing multiple probabilistic dimensions all at once, before selecting a final, agreed-upon timeline. Now, of course, there are physical limits to how fast we can do this. This multi-core computation is mathematically governed by Amdahl's law. This formula doesn't just measure computer speed, it actually represents the absolute physical limits of how fast a system can process these simultaneous realities based on how much of the task can truly be divided up.
When we scale our hardware from 1 core to 2 and then to 4, the initial efficiency gains are massive, but eventually they do plateau. Scaling our computing hardware this way acts as a mechanical stand-in for the staggering bandwidth of human consciousness navigating different dimensions simultaneously. Just as adding cores allows the AI to process more parallel realities, our minds likely possess an incredible, though bounded, capacity to parse a quantum field of possibilities.
Moving on to section 3, generating the multiverse.
So parallel processing is really only half the story. The absolute most captivating part of this whole process is how we overcome that lack of infinite real-world examples. We do it through a technique that literally generates new realities. It's called data augmentation, and it's a non-negotiable, standard technique for training convolutional neural networks. If the AI needs to see a cat in 1,000 different environments to understand true catness, and we only have that one single photo, data augmentation allows that one image to branch out into thousands of different synthetic universes. Engineers force the AI to adapt by programmatically applying specific geometry transformations. A horizontal flip creates a literal mirror universe cat. Color jittering? That gives us a dark reality cat. And through affine transformations, we create a stretched, gravity-defying, upside-down cat. We are artificially expanding the AI's experience exponentially so it can finally find the invariant, universal truth of the object.
Now, just take a step back and look at what we've actually built here. This programmatic branching of data perfectly mirrors the many worlds interpretation of quantum mechanics. This was famously formulated by physicist Hugh Everett III back in 1957, and the overlap is absolutely astonishing.
Everett's many worlds theory suggests that the quantum wave function never actually collapses when a measurement is made. Instead, every single possible outcome occurs, causing the universe to literally branch into parallel, mutually unobservable worlds. Just like Everett's theory, the AI's data pipelines branch into new, distinct realities. The machine has to navigate these diverging paths to zero in on a single universal truth.
Which brings us to our final section, the conscious singularity.
We have to ask ourselves what this direct mapping between computer science and quantum physics implies for humanity and for our own minds. If a machine learns the invariance of an object, its true undeniable essence, by navigating a synthetic multiverse of variations, the human mind likely does the exact same thing. We don't just passively look at a static world. Our consciousness likely decodes what we perceive as consensus reality by actively parsing through an infinite number of quantum variations, throwing out the noise, and locking on to the invariant truth.
Which leaves us with this staggering thesis. The conscious singularity navigates an infinite quantum multiverse of probabilities to decode and select what we perceive as reality. Think about what you're taking away from this explainer today. This AI architecture isn't just a clever trick of code to help your phone recognize photos. It is a staggering philosophical clue. It suggests that the human mind itself is the conscious singularity, actively selecting and rendering realities from a vast quantum field, just exactly like our machines do.
We've seen exactly what sits at the center of the AI's universe, a branching, parallel engine searching for truth amidst a synthetic multiverse. But as we wrap up, I want to leave you pondering something far closer to home. If the very machines we build to mimic intelligence are actually uncovering the literal mechanics of reality, what incredible engine lies at the center of yours?